Remember, in our previous video, we discussed what speed is. Let's quickly recap. Speed is simply distance divided by time. That's it, distance upon time. Now, before we talk about the different units of speed, we first need to talk about the different units of distance and time. But even before that, let's ask, what is a fundamental unit of speed? How do we find it? From the formula itself. Distance is measured in meters. Time is measured in seconds. So the unit of speed becomes meter per second, written as m per second. As simple as that. But of course, we don't always measure in meters and seconds. Remember from our lessons on time, we saw the time can be measured in seconds, minutes, hours, days, and so on, depending on whether we're measuring something short or long. It's the same with distance. If you had to measure the distance between Kashmir and Kanyakumari, we would use centimeters or even meters, right? You would use kilometers because that's a much bigger unit. So what are the common units of distance? Kilometers, meters, centimeters, and millimeters. And since the speed is derived from distance and time, its units changes depending on which unit we choose. For example, kilometer per second, km per second, meter per second, kilometer per hour. Now, how do we convert between these? We need some basic conversion facts. 1 day is 24 hours. 1 hour is 60 minutes. 1 minute equals 60 seconds. And for distance, 1 kilometer is 1000 meters. 1 meter is 1000 centimeter. And 1 centimeter is 10 millimeter. These simple relationships help us translate from one unit to another, whether we are working with time, distance, or speed. Depending on the need and the context, speed can be measured in different units. And since speed equals distance divided by time, different combination of distance units and time units gives us different units of speed. In the SI system, unit of speed is meter per second, written as m per second. But another very common unit, one we use in daily life, is kilometer per hour, written as kilometer/h. Now, it's important to know how to switch between these units. For example, if the speed is given in kilometers per hour, how do we convert it to meter per second? And if it's given in meter per second, how do we change it back to kilometers per hour? Let's start with the first conversion, 1 kilometer per hour to meter per second. Remember, speed is derived from distance and time. So we convert the distance first. 1 kilometer is equal to 1000 meters. Then we convert the time. 1 hour is equal to 3600 seconds. How? Because 1 hour is 60 minutes and each minute is 60 seconds. So 60 times 60 is 3600 seconds. Now, 1 kilometer per hour can be written as 1000 meters upon 3600 seconds. If we simplify this, cancel the zeros and reduce further, so we get 5 by 18 meter per second. So 1 kilometer per hour is 5 by 18 meter per second. This is our conversion factor. Now reverse it. 1 meter per second to kilometer per hour. First, convert the distance. 1 meter is 1 upon 1000 kilometer. Then the time. 1 second is 1 by 3600 hour. Speed is distance upon time, so 1 meter per second or 1 meter upon 1 second is 1 upon 1000 kilometer divided by 1 upon 3600 hour. Dividing by fraction is same as multiplying by its reciprocal. So this will look like this, 1 upon 1000 kilometer multiplied by 3600 upon 1 hour. That gives us 3600 upon 1000 or 36 by 10, which can be further simplified to 18 by 5. So 1 meter per second is 18 by 5 kilometer per hour. That's our reverse conversion factor. Okay, let's try to apply what we learned here. Okay, we have a situation. A person seated beside the driver recorded the distance traveled after every 10 minutes by noting the distance reading in the odometer. Odometer is the device that reads the distance, right? The distance traveled by the car at different instances of the time is as follows. The table is given. Find the distance traveled by the car in kilometer per hour and meter per second. Let's find the speed of the car in both kilometers per hour and meter per second. From the table, we see in the first 10 minutes, the car travels 15 kilometer. In the next 10 minutes, it travels 10 kilometer, then 13 kilometer, and finally 23 kilometer. So in each equal time interval of 10 minutes, the car is covering unequal distances. Remember, when a vehicle covers unequal distances in equal intervals of time, this is called non-uniform motion. Now, since the speed is changing, we can't just take one value, right? We need to calculate the average speed. So average speed is actually the total distance upon total time. Now, The person who was sitting next to the driver took some odometer reading, right? From the table, it is clear that the odometer reading, the total distance traveled is 60 kilometer and the total time is 40 minutes. That means total distance is equal to 60 kilometer and the total time is 40 minutes. Right? Let's convert this minute to hours because we need our answer in kilometer per hour first, right? So 1 minute is 1 by 60 hour. That means 40 minutes is equal to 40 by 60 hour, or simplifying we get 4 by 6 hours. Now plugging into the formula, average speed is equal to 60 kilometer divided by 4 by 6 hours. Dividing by fraction is same as multiplying by its reciprocal. So 60 times 6 by 4, and 4 goes 15 times in 60 because 4 into 15 is 60, and 15 into 6 we get 90 kilometer per hour. So the average speed is 90 kilometers per hour, but we also need answer in meter per second. We know the conversion factor. Remember, 1 kilometer per hour is 5 by 18 meter per second. That implies 90 kilometer per hour is 90 times 5 by 18 meter per second. 18 again goes 5 times in 90. That means 18 into 5 is 90, and we have 5 times 5 is equal to 25 meter per second. Therefore, the average speed of the car is 90 km per hour, which is same as 25 meter per second. And remember, this was a non-uniform motion.